Hi guys, so today I'll be showing you how to do an implementation of a stack data structure. So I'll show you how the implementation works, and we'll be doing the implementation of an array stack. So it's of a stack ADT or stack abstract data type. So we'll start with our stack ADT class. So it's you're gonna define three classes if you're following along in your IDE. Define a main.java class, define an empty collection exception.java class, and define an array stack.java class, so three classes, and then do create one interface and call it stack ADT.java. So I've already created those, so I'll start with this interface. So we'll write public interface stack ADT, and then it's of generic type T. And so we will try to write some of this in Java doc. Hopefully I can remember the exact syntax for it. So we'll start with interface. So remember, an interface, a Java interface, can hold constants and method headers with parameters, but no method body. And at the end you put a semicolon instead of brackets. So we'll start with the push method. So we'll just do public void push, and then it takes a parameter of T element. So it's taking an element of type T as a parameter. So we're going to be pushing something onto the stack. So we'll just write some Java doc here. So we'll say adds the specified element to the top of the stack, or this stack, and then at param element, I'll just write it out, at param and then element, and then element to be pushed onto the stack. So it's saying it takes the parameter element and it pushes that element onto the stack, and then it just closes the Java doc for that part. So then we say public void push, we've defined that, and then we will do the next method, so public void pop, and then we'll just do the Java doc here. So backslash asterisk asterisk, and then removes and returns the top element from this stack. And then at return, wait, no, not supposed to, oh no, it's not, sorry, it's not supposed to be void, it's supposed to be T, public T pop, and push was void, that's right, push was void, T is pop, I mean pop is T, sorry. Okay, so at return, where we removes and returns the top element from this stack, and then we at return the element removed from the stack. Public T pop, okay, that's right. Public removes and returns, okay, public T pop, and then we'll do public T peak, another method called peak. So remember in the stack video where we're just using the built-in stack data structure class in Java, all these methods are already defined for us. We just imported java.util.stack and then we called all these methods. So what we're doing now is I'm showing you how these methods were created. So we're kind of diving into the implementation. So now this is the peak method. We've used the push, the pop, the peak, and then we use the empty. And then I think in this one I call it isEmpty instead of empty. And then we also do the size method, and then we do another one called expand capacity. That's just for something else because we're using an array. But we'll just do the Java doc for this part. So public T peak. So returns without removing the top element of this stack. At return the element on top of the stack. Public T peak. Okay, that's public T peak. And then we'll do another method, public boolean isEmpty. So it returns either true or false. It's supposed to return true if it's empty and false if it's not. So we'll put slash asterisk asterisk returns true if this stack contains no elements. And then we'll say, well, we already said at return. At return, did I write that or did it automatically write it? I'm not sure. So at return, true if the stack is empty. And then we'll just close that. Is empty. Okay, one more. Actually, two more. We'll do size. So public int size. So we return. So backslash asterisk asterisk for the Java doc, and then we return, or it returns the number of elements in this stack. And then at return the number of elements in this stack. Close the Java doc, and then public int size. There you go. And then so we'll do one more. Public string to string. So toString returns a string representation of this stack. And then at, whoops, I already wrote that. At return a string representation of this stack. Put a, okay, let's leave it like that. So save it. I think that's everything. Push, pop, peak isEmpty, int size. So int returns an int, size returns a boolean, isEmpty returns a T peak, returns a T pop, and void push. Okay, T element. No, so the only one that takes a parameter is a push. Just keep that in mind. And then now we will move to the array stack class. So we'll start writing the methods for these. So we'll do public and then class array stack, and then we'll it's of generic type T, remember, and then we'll say implements. We're going to implement stack ADT, the interface that we just created of type T, and then start with that. We'll create some variables. So private final static int default capacity equals 100. Private int top, private T array stack. So we'll create an array there of type T. Then we'll create the constructor, public array stack. Whoops. Public array stack of public array stack, and it's going to take a parameter, and we'll call it int initial capacity. Then we'll open those braces and we'll set top equal to 0. And then we'll set, so you can't instantiate an array of type T, so we're going to have to cast it. So we'll say stack equals T array. Then we'll cast a T array to a new object of initial capacity. And that's going to give us an error. So up here, write suppress warnings. Suppress warnings, and then just put unchecked. Should go away, unless I spelled it wrong. Suppress warnings, S-U-P-P-R-E-S-S. Warnings, unchecked. Okay, we'll come back to that. It should disappear eventually, I think, unless I have to like do the whole Java doc for this whole thing. So we'll do the first method. What's up with this? Public class. Okay, we haven't implemented all the methods, that's probably why. So we'll do public. So we'll start implementing the methods that we created in our interface. So we created push. So we'll go into our array stack class, and then we'll start implementing these methods. So public void push, that's what we called it. It takes T element, exactly the same. And then now we'll write this method. Actually, we probably won't write this method. We're going to have to write other methods, so we'll just do it this way. If size, so let's write size. I shouldn't have actually done this, probably confusing and annoying. Probably should have just wrote size first. So let us just keep that there. And we will write the size method first because I forgot about that. So we will write public returns an int size, and then we'll say return top. Did we define top? Yes, we did. We said top equal to 0. Okay, so that should be fine. What else should we do right now since we're here? Okay, we'll just go back for now. So where were we? If size. So if size, equals to stack dot length equals to stack dot length, then we'll say we'll have to create this method, expand capacity, and it's gonna ask what is that. So we have to create it because the compiler doesn't know what it is. So it's a public void. Do we call it a void? I think we did. It's a public void. Did we even write it? No, we did not. Okay, so I think this is a private method. So private void expand capacity, and then we'll say stack equals. Did we call our array stack? Yes, we did. Okay, so stack equals. We'll call a method from the array class. It's called arrays.copyOf. Arrays.copyOf. And then what we're going to do is we're going to copy our old elements, and then we're going to take those old elements and multiply it by 2. Why are we getting an error for that? Did I spell arrays wrong? Arrays, ARRAYS dot copy of. Oh, you know what? We didn't import the class, I think. That's probably why. So let us import. So go back to the top of arraystack.java and then import java.util.arrays. I think that's it. Did it disappear? Yes, it did. Okay. So remember, if you're working with arrays, if you're going to work with a toString at least, just import java.util.arrays. If you're working with arrays, it's just helpful to just import that class. That way you don't have to do that later on. So arrays.copyOf, what it does is it copies the specified array, truncating or padding with nulls if necessary, so the copy has the specified length for all indices that are valid in both the original array and the copy. The two arrays will contain identical values. For any indices that are valid in the copy but not the original, the copy will contain null. Such indices will exist if and only if the specified length is greater than that of the original array. The resulting array is exactly the same class as the original array. So when I wrote this, arrays.copyOf, it takes the old array and it copies it to what you want, like that. So old array and then new length, or it's old length and then new length. Stack, okay, yeah. So it's the old length and then the new length. So I think you can just put an integer in here of indexes if you really wanted to. So you could have wrote like 100 or something. And then we're copying our old stack and we're putting our new length. So for that, that's all we have to do. So just remember that, and then we'll go back to the top, or not top, to the push method. So we're back at expand capacity. So we're saying if size is equal to stack.length, then expand capacity. So if the size of the array is equal to the stack.length, so let's say our array is like 5, or there's 5 elements in the stack, and our array is, remember, because when you initialize an array, you have to initialize it to a certain number of elements. So if it's saying the size of our array stack is equal to the size of our array, then expand the capacity of the array so we can continue to push elements onto our array stack. That's all it's saying. So from there, we will go to the next method, which is the push method. Oh wait, no, sorry, we didn't create all this. So we still have to do one more thing. So we have to say, so back to our push method. So we'll say stack of top, and then we'll set it equal to element. So stack of top, index top is equal to the element that got pushed on. So if right now if top is equal to 0, then it's saying our array stack of index 0 is equal to the element that just got pushed on. So now inside index 0, this element is now contained. That's all it's saying. So we set it like that. Stack of top equals element. And then we'll just increment top plus plus. So every time top's going to increment when we push something on, so that it's keeping track of the stack. It kind of works like a counter. So then now this method is complete. Public void push. Just save that just in case. And then we'll go to the next method. So it's public t pop. We've already defined it in our interface. And then we'll throw empty collection exception. We haven't created it yet, but you'll see what it is after. It's an exception that we're going to create, a custom exception. So we'll just write that public t pop throws empty collection exception, and then we'll say if is empty. So it's saying if our stack is empty, because remember what does is empty do? Or do we even write it? No, we did not. I thought we did. No, we wrote size. Okay, let's write it. So is empty. So it's a Boolean method, so public Boolean is empty. So it returns top. So it returns true if top is equal to less than equal to 0. So just right here, just to make it clear, returns true if top is less than or equal to 0. So back up here where we just were, public t pop throws empty collection exception if is empty. So if our stack is empty, right? Because the way it's knowing that is it's returning true if top is less than or equal to 0. So if this is going to return true if it's empty, right? If it does, then we will say we will throw our collection exception. So we'll throw new empty collection exception. And then we'll just write stack in there. You'll see why after. So if it's empty, if our array stack is empty, throw a new empty collection exception to tell basically that all it's going to do is tell the user that our stack is empty or their stack is empty. So now we will go back here, and if that's if these braces miss because this returns false, so if it's not empty, then what we're gonna say is we're gonna decrement top, so it's gonna go back and index so we don't return 0 or null. Because if we return top, remember every time top increments by 1, because what does top do? Top returns the next element to be pushed in the stack or the size currently of our stack, right? So it returns stack.length or the next element into which an element should be pushed into the stack. So right now, if we didn't decrement it, if we wanted to pop something, it's not gonna go back. It's just gonna pop off a 0 or a null depending on what we put in there, right? So it would have probably popped off null at this point because there wouldn't have been anything in that. It's gonna look for an empty object. There's nothing there. It doesn't point to an object, so it would have returned null. So then after that, top minus minus, and then we'll create a local variable here. We'll say t result equals to stack of top. Usually it's easier to just write them up here, like t result, and then we could have just said result equals, but we'll just do it this way. Usually if you're writing like long methods, that might be easier just to keep track of everything at the top when you're looking for something, but for now we'll just do that. So t result equals to stack of index top. So all it's saying is this result of type t. So you can think of t like an int, like a car, like a string, right? But t is like an undefined. We've created this data type here, right? Or technically it's an object reference. It's a reference variable, object reference variable. So object reference variable result is equal to stack of index top. So we minus minus, right? Our top counter, it decremented by 1. Then the result of whatever it was previously holding in that position in our array, that's what it's returning. And then we'll just say return result. Why is this giving us a little error here? It's redundant. That's fine, doesn't matter. Shouldn't matter. Oh, did we not say, oh, we didn't do one more thing. We will say stack of top equals to null. That should work. Top minus minus t result equals stack of top. Stack of top equals to null. Return result. So we'll just write a little note here. Stack hold object refs of type t. So refs is just references, just for short. Type t, and then we'll say stack of the last index, what element it's holding equals to t result. So stack holds object references of type t. So the stack of the last index, what element it's holding, in brackets, is equal to t result. So this whole thing is kind of in brackets here. just to kind of make it clear. Hopefully that helps you understand what's going on. So it's just saying the stack of the last index, that's why we decremented it. That's why it goes to the last index. Then the element that it's holding, that's all stack last index is saying, it's saying the element that it's holding, and then we've set the element that it's holding equal to t result. Well, just result, but result of type t. So then here all this statement says is current index is popped and set to null or 0. That's why we set stack of top equal to null. And then here we just returns result or element object. Remember, we're holding object, so the element is an object, and then popped. So returns result or element object popped. Okay, save that, and then we'll just do the other method, peek. So public t peek throws empty collection exception again, and then so we'll say if is empty, throw new empty collection exception stack, and then if that's not true, then we'll say return stack of top -1. So all it's returning is the element in our stack of the top, current top, and then we're going to -1 element. Because remember, if we just return top, it's going to return a null or a 0, because top returns the next element which to be pushed, and or it returns which is a stack length, right? That's why we have to decrement it by 1 or -1, so that way we can peek at the last element at the top of the stack. We actually don't think we need these here. We'll just do that like that. Well, maybe we could try that. I like using them, it just helps it make more clear. But might have to relook at it after. So for now, what else do we have to do? We've done. Why is this like still like that? Annotations are not allowed here. Okay, we'll just save that for now. So public void push, public void peek. Oh, sorry, public void push, public t pop. Then we got pop, peek, size, is empty, expand capacity. We're missing something. Oh, the toString, right? That's right. So we'll do public string toString, and then we'll just say return arrays dot toString of stack. Save that. So that just returns a string representation of our stack. and then that should be all. Suppress warnings, uncheck. I don't think that's supposed to have a semicolon. There we go. Okay. So we'll go to our empty collection exception. We're almost done. This is kind of a long video. It's not as long as the other one on the stack postfix evaluator, but we'll just keep going. So public class empty collection exception. And since we're creating an exception, a custom exception, we'll have to extend exception or runtime exception. We can also do runtime exception. I think we can try that first. Extends exception. We'll create the constructor because that's all you have to do. Public empty collection exception, and then it's going to take a parameter string collection, and then we'll call the super reference to reference appearance constructor, and then we'll say the collection, the plus collection, plus is empty, semicolon. That's all I think. Why are we getting related problems here? That's fine, we'll just come back for now. So public class empty collection exception extends runtime, or no, extends exception. So we'll go to main, and then we'll just do the same thing. So we'll just do public class main, public static void main, string array args. Then we'll say so we'll call our class array stack, and so in a generic type we're gonna have to, so in our array stack class it's in a of generic type T. So in our main class we're gonna have to instantiate that generic type T with some kind of object. So we could hold anything in here, but we'll just hold integers since it's easy. We'll just call it stack1, and we'll say new array stack of integer type. We'll say initial capacity of 10. Because we created two constructors here, I think, did we? Or did I only do one? Yeah, I only did one. Wait. Yeah, I only did one. I originally thought we were going to do two, but it's okay, we'll just do one. So we'll say stack1.push 1 on there. We'll say stack1.push. We'll push 2 on our stack. We'll do stack1.push, and we'll push a 3 on the stack. Call stack1. and we'll dot push. We'll push a 4 on the stack. So this is a stack, right? This is the stack that's created in Java in the stack class, and we've created our own implementation of the stack class. So now we're just pushing our own methods on there. Does the same thing. So we'll push like 100,000 on there. Then we'll system.out.print. We'll print our stack 1. Save and run. Here we have some overridden method does not throw stack ADT. What method is that? Peak. Peak. And we say throw. Public void push T element. Public T peak. Okay, so public T peak throws empty collection exception. If is empty, throw new. Are these messing us up? See if that works. Okay, no. Public T peak throws empty collection exception. Did I spell it wrong? EXCEPTION. No. If is empty, throw new empty collection exception. Empty collection. Did I spell this one right? Empty collection exception .java. Might have to extend runtime exception. Let's try that. Okay, now it works. Hopefully. Yeah, okay, so now it works. My mistake. See if that runs now. Okay, it does run. So what we did is we created a stack. We created an array stack of type integer, right? So our array stack is holding integers, objects, and we called it stack 1, and we set it equal to new array stack of type integer, which is what it's holding. And in these brackets here, we said that we have a it takes an initial capacity, right, as a parameter. So then we had to input initial capacity. What we could have done is we could have scanned in something from the keyboard, like a user input that the user could have typed. So we could have said, like, I can just show you. We can do we could have done import java.util.scanner. Then I could have created something in here like int. Will int work? We'll try it. Int. Let's just call it user input. Then we could have said like system.out.print line. We could have said enter initial capacity. Then we could have set user input equal to scan.nextInt. We can try saving and running that. Oh, whoops, sorry. Then we could have put here oh, sorry, we didn't even create the scanner, so let's do that. Scanner scan equals new scanner system.in. Then we could have set this to user input. Should work unless we have to change that into a wrapper. Where am I missing that? Line 9. Isn't there an equal sign there? Okay, there we go. Enter initial capacity 10. So it worked. Could we have set integer here? No, we could not. Okay, that's right. Because we would have had to do new. We've had to use the new keyword to instantiate an integer object. So integer user input 2 equals new integer. That should work. Would we have to write something here? Yes. Yes, that should be right. So then we could have just done that. And then put user input 2 in there. So it's like the same thing. But that's unnecessary, it's telling us, so we'll just keep it this way. So from there, we will continue with this. So we've created our stack implementation, array stack implementation of a stack ADT, which is a stack abstract data type. And we will then continue to just testing it out. So what other methods did we create? We created pop. So let's do this. Let's put some more elements on here. We could have used a for loop to do it, or a for each loop, but we could just do it manually. So stack.push, push like that on there. Then we'll push. We'll just push like something random like that. Stack. How many do we have? 1, 2, 3, 4, 5, 6, 7. We'll just do one more. Stack.push. Something like that. And why did that not work? Too large for an integer, okay. So then we pushed stuff onto the stack, so we'll print it out. Enter an initial capacity. Oh yeah, we're still doing that, so we'll just say 10. So that's our stack. So now we can pop some stuff off. So we can pop like, let's just change these to like some easier numbers. 1, 2, 3, or 4. So stack 1.pop, and we'll pop the last element on the stack, and maybe we'll write here system.out print line, and we'll write you popped off, and then we'll write plus, and then we'll put a bracket here, or parentheses. Save and run that. So it says you popped off 4, because 4 was the last element on the stack, so we can print it out again. Just copy this. So then it should write the stack out again without the 4. As you can see, that 4 was popped off. So we demonstrated the push method, we've demonstrated the pop method. Let's demonstrate the peek method. So we'll do system.out.print line, and then we'll do peek. We'll call stack 1 dot peek method, semicolon on that, save and run it. So enter an initial capacity, so we'll just do 10 again. It's kind of annoying to do this every time, but that's okay. So we peeked at the top element on the stack, and why do we write that twice? Sorry. Let's run that again. So we peeked at the top element on the stack, which is a 2, and it returned a 2. So there's that method, and then there's the isEmpty method. So we'll system.out.print line, and then we'll write stack1.isEmpty. Save and run that. So it should return false because our stack is not empty. So remember, isEmpty returns true if our stack is empty. In this case, it returned false because our stack is not empty. So then now we can call the last method that we made. So we can say, system.out.print line, call stack1 with a dot operator, and then we'll write size. So what does size do? Size returns the number of elements in the stack. So save and run that, and it should return 1, 2, 3, 4, 5, 6, 7. So return 7 because there are 7 elements currently in the stack. So again, if we would have just done stack1.push, something like that, and then we would have wrote system.out.print line, and then if we would have called stack1.size now, it should have increased that value by 1. So our stack now is 8. That's why 8 was written there. So that's all the methods that we created today in our stack implementation, in our stack ADT array stack. So it's we did the stack implementation using an array stack of a stack abstract data type. And so I hope that helps you understanding stack ADTs and how a stack is implemented. So I hope that helps. See you later. Thanks.